Hello, fellow seekers of knowledge. Ernis here, ready to plunge headfirst into the fascinating world of robotics and artificial intelligence. Today, we're cracking open a paper that's not just about robots doing stuff, but about robots learning how to do stuff. Like, real world, oops, I messed up, let me try that again, learning. Fine, yeah, I guess. The paper is called Learning Affordances at Inference-Time for Vision, Language, Action Models. Now, before your circuits get overloaded, let's break it down. Imagine a robot arm trying to tidy up your chaotic workspace. It's got a goal, empty 2 of the bowls. Sounds simple, right? But the robot is like a cosmic toddler. It doesn't know which bowls are easy to grab from, which objects are too slippery, or which actions will lead to glorious success or utter failure. This is where the magic happens. So, how do we teach this robot? The researchers behind this paper, Amish Shah, William Chen, and their team at Berkeley, propose something they call LITEN, learning from inference-time execution. Think of LITEN as giving the robot a little voice in its head that says, "Hey, remember when you tried to pick up that pineapple can and failed miserably? Maybe try something else this time." Now, let's step into our memory palace. Picture a vast, interconnected robotic research facility. In the first room, we have the vision. This room represents how the robot sees the world through cameras and sensors. It's raw data, like the unfocused image on a telescope before you adjust the lenses. In the next room, we have the language. This is where the instructions come in, empty 2 bowls. The robot needs to understand what that means. Then we have the action. This is where the robot's muscles kick in, and it starts moving its arm. The paper has 2 major sections. It's like building a cosmic sandwich. The first part is reasoning. The robot gets an instruction and tries to figure out a plan. It's like a cosmic game of chess. The robot thinks, okay, to empty these bowls, one need to pick up stuff and move it. But here's the twist. This robot has a secret weapon, a vision language model, or VLM. Think of it as a brain that's been trained on tons of images and text. The VLM helps the robot understand the world and come up with a plan. But what if the plan fails? That's where the second part comes in. Assessment. The robot reviews the robot's performance in the physical world and figures out what went wrong. It's like the robot is saying, okay, I tried to grab that bowl, but my gripper couldn't fit. I need to remember that for next time. The robot takes what it learned and adds it to the context for future attempts. So, the next time the robot tries to empty the bowls, it's a little bit smarter. The cool part is that LITEN doesn't require any additional training. It uses off-the-shelf VLMs. It's like giving your existing robot brain a software upgrade that makes it way better at learning from its mistakes. The researchers tested LITEN on a real robot with 3 different tasks: stacking objects, emptying bowls, and moving objects off a table. Imagine the robot arm in the lab struggling to stack blocks atop one another, or meticulously moving objects between bowls, each attempt refining its understanding of physics and spatial relations. The results? LITEN consistently improved its performance as it gained experience. It learned which objects were easy to manipulate, which bowls were easy to reach, and which actions were most likely to lead to success. Now, you might be wondering, what's so special about this? Well, other methods for teaching robots often rely on simulations or pre-programmed behaviors. LITEN, on the other hand, learns directly from its experiences in the real world. It's like learning to ride a bike by actually riding a bike, not just reading a manual. Of course, LITEN isn't perfect. Sometimes, the robot makes mistakes because it misinterprets the instructions or because the environment is too unpredictable. But even in these cases, LITEN learns from its mistakes and gets better over time. So, what's the takeaway? LITEN is a promising new approach for teaching robots to learn in the real world. It allows robots to adapt to new environments and tasks without requiring additional training. It's a step toward creating robots that are more flexible, adaptable, and useful in a variety of settings. Now, I know what you're thinking. This is awesome. I want to learn more. Well, I encourage you to check out the full paper. Dive into the details of LITEN and explore the exciting possibilities of inference-time learning. It's a cosmic adventure that's just beginning. Thanks for joining me on this journey. Keep exploring, keep questioning, and keep pushing the boundaries of what's possible. I'm Ernie, and I'll catch you on the next episode of PaperLedge.